Greetings, members one and all of the Salivation Nation, with a little different video this time with regards to precious metals, and gold is what we're looking at here. This little device that you see before you here is part of an unusual struggle that gold is going through in its fight to resist oxygen. Let's explore! Now, what would this particular piece do to serve in that fight? Well, this is a blown up image of a pin, actually, developed by the European Space Agency. And why did they choose gold? Well, we're going to talk about it in this video, but we're also going to have to understand a little bit about gold. You know, you've heard me talk about it in past videos. One very recent video where people have unearthed a gold coin that was in the ground for over 2,000 years and had no reaction to the processes over time and being inside of the dirt in the ground for that long. The gold still shone bright as if it was been buried yesterday. And that is one of the attractive natures, one of the attractive characteristics of gold, is that it does resist decay. And well, not only that, it pretty much is immune to it. It does not react. So not only does it pay dividends in and of itself because of the nature of what it is as a wealth preserver, but its physical characteristics are what helps us bolster that status. Its status symbol of wealth and rarity and expense is quite intriguing. The European Space Agency has developed this gold pin, and it's not much bigger than the tip of a pencil. It is the pulsing heart of the European Space Agency's Low Earth Orbit Facility, LEOX, part of the agency's Materials and Electrical Components Laboratory based at ESA's ESTEC Technical Center in the Netherlands. This test facility is vital for developing materials capable of withstanding the highly erosive individual oxygen atoms prevailing at the top of the atmosphere, the result of standard oxygen molecules of the same kind found just above the ground being broken apart by powerful ultraviolet radiation from the sun. All missions that orbit less than about 1,000 kilometers above the Earth's surface must be designed to resist atomic oxygen. To realistically simulate the low Earth orbit environment, the LEOX Atomic Oxygen Facility generates atomic oxygen traveling at 7.8 kilometers per second. So yes, indeed, unusual, but it is fighting oxygen, atomic oxygen at that speed. It is not easy to generate on Earth because it is so reactive. This means that the materials used to make the simulator must be as robust as the materials flown in space. This sturdy little gold pin is used to inject tiny pulses of oxygen gas molecules into a vacuum chamber, where the molecules are split into atoms using a powerful laser. Pure gold, though expensive, is one of the few materials that can resist the combined impact of the laser and the highly erosive atomic oxygen. Think about the speed that the atoms are traveling, allowing the simulator to pulse millions of times during each test campaign. The pins do eventually erode. I mean, after all, gold is the most malleable and a very soft metal, and so they do need to be replaced from time to time. But it's not because atomically it's being altered by any way. It does not react to the oxygen other than just the speed of the laser and the atomic oxygens putting stress upon the metal itself. They can't be found in a local hardware store because remember here, this thing is merely the size of a pencil tip. It's very, very small. It doesn't really say how much it weighs, but my guess is it probably weighs probably less than a gram is my guess. probably less than a half a gram, maybe even a quarter gram, but who knows? Engineers had to search far and wide to find a reliable supplier. With the help of Eastech's mechanical workshop, they found the jewelry shop in Italy, which offered to manufacture the pins. Using their experienced supply of miniature mechanical gold parts for clockmakers and other industries. Yes, indeed, gold is used as well as rubies in the watchmaking industry and clock. So there we go. So, and that is what is happening here. This is how gold can help with the space program and with the harsh conditions that we see in space and especially in the upper atmosphere. And though this video may trigger those of who don't believe in a oblate spheroid or the fact that we can get into space, take this for account as a sort of a think of it as a compromise. This is for data and space flight that happens just above the atmosphere. So, but nonetheless, there it is, the gold pin, a very high magnified blow up version of this, and this pin is fighting to resist oxygen. And it is a fascinating tale here to see what's happening with the with gold and how it's being utilized in industry, and especially gold, which really there's no other metal like it to be able to perform this kind of function. Obviously, silver does tarnish, does react, and other than the fact that gold is soft, they need the pure gold in order to be able to provide this least reactive state. So it is very durable in that regard, even though it is very malleable, obviously, and ductile. But there it is. Fascinating indeed. The gold pin that has in the European Space Agency. Now, we do know that gold has also been utilized on the mirrors of like the Hubble James Webb telescope, and is utilized for the shields on the space for the visors for the astronauts and the like, and utilized many different avenues and ways here on Earth as well for science, technology, the biomedical field. But it is a very expensive metal, so likely if it's being used, there's probably not a viable substitute to take its place. And really, gold, because of its expense, because of the nature of what it is, it's not as widely used as silver in industrial, biomedical, and technological applications, but it's still being utilized. Silver is much more diverse in that area. But nonetheless, these metals, precious metals in general, gold and silver, but you can also lump the platinum group metals in there as well for their catalyst properties. They are amazing metals indeed. And I think it's going to be quite a long time before they are replaced by such technologies that we've heard about, graphene being the big one. There was a talk about that a couple of years ago, that graphene very well may replace silver, especially in like photovoltaics and the like, and other applications. But the fact remains, it's very difficult to mass produce. It requires an insanely sterile environment, and it's just not there. Graphene, very tough to get, and we've just not made it possible to become economically viable to replace gold and silver. Gold continually being used, and there probably will be ways to be able to find a measure to be able to alloy it with perhaps with other metals, or to use less of it to do the same functions. And in fact, we are seeing some of that in other industries for silver. And gold is the same thing. But to have one of these things in your collection would be kind of nice, but very, very tiny. My guess, again, maybe half gram at the most. Maybe this little pin weighs, think about the end of a pencil. It's gotta weigh less than a half a gram is my guess. Gold is a very dense element, so it's very difficult to really tell. But a fascinating story indeed. Let me know what your thoughts are. And do you know of any other unusual applications for gold? Who would have thought that gold would actually be there to fight and resist oxygen? Of all the things that you could think of. I hope you enjoyed this video. If you do like videos like this, I hope you will consider subscribing to the channel, pressing the notification bell, pressing the like button does help to get the word out. Trying to grow the channel here, and a little comment, even if it's just something like algorithm food or here watching or something like that. So a multitude of gratitude to you all for taking the time to watch, and I want to encourage you to please rate, share, comment, and subscribe.